All right, everyone. Today's guest is my good friend, Arye Lipman. How's it going, Arye?
Doing good. Yeah, thanks for having me.
Arye is someone that I've known for a few years now, and he was instrumental in helping me launch the fund that Sam and I now run, back when it was called Empath Ventures. And at that time, Arye was a VC, and now he's an operator working in the very interesting field of biomanufacturing, which is something that when I met Arye, I didn't even know was a field. And I have a suspicion that a lot of people don't even know that it's a field, even though it's absolutely massive and critical and increasingly important and critical. So this episode is going to be sort of a walk through high-level lesson and understanding of biomanufacturing. And Ari's going to lead the way, and Sam and I are going to ask the dumb questions. And I think it's going to be fun. So, Ari, why don't you just tell us at a high level, like, what even is biomanufacturing? What is it? Why is it important?
Yeah, I mean, I think the thing to start with is the field of biotechnology. And biotechnology at a high level just means engineered biology, specifically engineering genetic code to change the way biology behaves. So that's sort of the field of biotechnology. And the biotech kind of dates back to sort of the late 70s, early 80s. The first true biotech company was this company called Genentech, which was a company that developed this way to engineer E. coli, which is a type of bacteria, to make insulin. Before this, insulin was derived from pigs, basically. So they had to process...
suck the insulin out of the pig
pretty
with
much
a needle or something.
Well, yeah,
Or
the pigs were dead.
Like,
The pigs,
sure.
the pigs were dead. So they just collected tons and tons of pig pancreases from a slaughterhouse, and then process those to make very small amounts of insulin for human use for diabetes. So Genentech figured out how to engineer, basically piece together a little piece of DNA, put it into a bacterial cell, and that DNA coded for human insulin. So that was the first sort of biotech product that ever came to market, I think sometime in the 80s or early 80s. From there, this field continued to grow, and the leading edge of biotech and ultimately biomanufacturing was really biopharma for a number of decades. So drug development in particular was sort of the area where there was the greatest utility and greatest value seen by the market over the course of 10, 20 years. But the technology underlying it became kind of more widely available and started to disseminate through various industries. So this technology of engineering genetic code to produce a protein or to modify a organism to do something started to be applied in other areas. So you have things like biofuels. So biofuels are made with biomanufacturing. You have things like probiotics, which are healthy microbes that are used in food and nutrition. So these engineered living systems kind of propagated out through various industries, and the field of biomanufacturing is sort of an umbrella term for using these engineered organisms to manufacture products of value to humanity in some way.
The dumb version of that explanation that I give people when they ask me, I'll tell you, and I want to know if it's actually correct, because I'm not sure if it is. I might be spreading disinformation.
Okay.
So I give the analogy of, hey, everyone, pardon the interruption. I just want to let you know that if you're an accredited investor and you're interested in investing in brain-computer interfaces, companies like Neuralink and Synchron, we're hosting a live brain-computer interface investor event on July 8th. If you want to learn more, check out beyondneuralink.com. Okay. Back to the show. You know how beer is made in these big old vats, and it's basically yeast, which are living organisms. Mm-hmm. The yeast, as they eat the sugar, they excrete alcohol, more or less. And biomanufacturing is basically, what if we genetically modify the yeast or the E. coli or some other microorganism to, instead of alcohol, excrete something else that we want? Is that more or less correct?
Yeah, that's more or less correct. In that instance, you're using a biological system to make something that you want, in particular, like a single cell biological system. So there you're making beer, but in today's sort of modern biomanufacturing, you're engineering these systems to make a whole wide range of different products. Very, from a high level, it looks very similar to beer brewing from a distance.
And I guess the next question then is, okay, if it's possible to create these products by genetically engineering some sort of microorganism to make it for you as a byproduct of its growth, Like, why do that versus just, whatever the alternative is, like some chemist in a lab with test tubes mixing chemicals around? Why can't you just create it like that way? Why do you have to genetically engineer some microorganism to make it for you?
Yeah. I think the first reason, which is maybe the best reason, is that biology is really good at making super complicated things. So, biology, if you just kind of look at the living world around us, is capable of making extremely complex things, including human brains.
Sure.
So there's a huge class of compounds that potentially only biology can make. So I guess that's sort of one answer. The other answer is that maybe there's a few others, but at least one other is that you can start with a very simple feedstock like sugar, and turn it into really complicated and valuable things in a pretty safe and innocuous way using biology. So there's very few hazardous chemicals required. It's generally a kind of a safe way to make chemicals, as opposed to a lot of other chemical manufacturing.
Yeah, like in the case of beer, you're literally just feeding them sugar and then you get this valuable alcohol. Yeah. And I imagine that most of the other biomanufacturing processes also some relatively simple input like sugar or some sort of fructose or something that the microbes can eat. Whereas if you were making it in a lab, you would need like some sort of petrochemical thing that might be explosive or might be toxic and just really hard and cumbersome.
Yeah, and that's the other sort of adjacent point, is that if we are trying to get away from using solely petrochemicals as precursors for all these processes, then biology is a good way to do it.
Yeah. And so, I mean, and the other point that you made is that there are some things that are just only possible to be made, or at least it's much easier to make them in this biomanufactured way versus the traditional kind of petrochemical synthesis, just because nature has this way of being able to synthesize really complex molecules. By the way, from what I understand, insulin is quite a complex molecule. If you actually like pull up a picture of insulin, you look at it and it's like, whoa. I don't know how any person can synthesize that.
Yeah, and that was sort of why Genentech had to use a microbe to make insulin, because they couldn't have synthesized it chemically. It would have been way too complicated.
So if it has those advantages, how come everything isn't made with biomanufacturing then? What are the downsides?
Yeah. I think the sort of obvious thing to say is cost. The first products that came out, like I said, were drugs, and those are very valuable products, probably on the order of $1 million a kilogram for maybe not insulin itself, but some of these biologic drugs, for example, that are currently made using biomanufacturing. They're very, very, very valuable. So the sort of juice is worth the squeeze in terms of manufacturing cost. For many other products that are low value, commodity, huge markets that you could point to, using petrochemicals as a feedstock is the right path, at least today, because petrochemicals are extremely cheap and widespread.
So you talk about the cost. I mean, what part of it is expensive? Is it doing the research to figure out how to engineer the microbe? Is that the expensive part, or is there another part that's expensive?
Yeah, engineering the microbe is definitely complex and can take a fair bit of time. But if you do find one, or you do engineer one that works, then you can kind of amortize that over the course of 10, 20, 50 years of production.
Sure. Yeah, once you figure it out, it's going to work
It's
forever.
kind of like R&D around a drug where, if you get that R&D done, your trial's done, then you can just make it and you have your patent protection for whatever it is, 20 years. I think a bigger factor, there's a number of factors that go into it. For sure, feedstock is one. Like there is some floor on the cost of sugar. Sugar's not too expensive. We're fortunate here in the U.S. because we do produce a lot of sugar. So nominally our sugar should be relatively low price. There are places with lower price sugar, but feedstock is like part of the floor of the price of any given thing. If you're spending $1, if you're buying sugar for $1 for every kilogram, then your thing better be worth more than $1.
Sure. Got to feed those microbes some highly subsidized high fructose corn syrup.
Yeah, exactly.
Get those prices down.
Yeah. Which is, again, I think one of the reasons that, nominally the U.S. should be leading in biotech is because we do have great natural resources to feed to these microbes. Lots of corn. So feedstock is one thing. Sort of our thesis, and we can get into kind of what my company Biosphere is doing, is that the infrastructure itself is far too expensive, both from a CapEx and an OpEx perspective. So the physical facilities, the operational overhead, the labor, to adequately sort of meet the needs of a lot of these new markets. So basically building biomanufacturing facilities and operating them is very costly. Now, it's also very costly to build a oil and gas refinery.
Right.
But that industry has been around for 100 years and has had a lot of time to eke out efficiency, and they're also really, really, really large.
So part of the reason why it hasn't taken off more is just because it's a more recent industry versus traditional chemical manufacturing.
Yeah, there's definitely a level of
kind of just like an
industry
incumbent
maturity
advantage kind of thing.
Yeah. And up until recently, there weren't really a lot sort of incentives to try to bring the cost down because the focus was mostly on products that were relatively high value, like these drugs, for instance.
And you guys, Biosphere, by the way, which is the name of the company that you are running, and we'll talk about Biosphere. You guys have this really cool paragraph on your website talking about the manufacturing process. There would be no American Industrial Revolution without the Bessemer steel process. There would be no mass market automobile without Henry Ford's assembly line. There would be no personal computer without Intel's 4004. And without a revolution in the architecture of the bioreactor, there can be no biomanufactured future. Did you write that?
I think I wrote part of it. I collaborated with my co-founder on that sentence, I think.
I always like when people kind of like draw parallels from, iconic things in the past. But when most people do it, they always have like some reference to Steve Jobs, which is super corny at this point.
Right.
And I think it's cool that you were able to do that without invoking Steve.
Yeah. We tried to go for sort of a more of a historical, non-obvious context. And both myself and my co-founder have read a lot of history about, the way the industries have developed. I think it is interesting just to think about technological shifts that are driven by what seems like kind of a single invention. And there are a number of them out there.
It's true. And it is funny to me that I don't think people today, when they hear like Bessemer Venture Partners, even make that connection between like, oh, that was the people that created the steel. And what I think is even cooler about it is that it wasn't like Henry Ford. Bessemer wasn't the guy that ran the company. Mm-hmm. He was the engineer that invented the process. And the guy that owned the company was like, that's so important to everything that we're going to name it after him. We're not going to take the credit.
That is pretty cool.
That's rare nowadays.
Cool. That's never done these days. That's amazing.
If it was done today, it would be the Zuckerberg steel steel manufacturing process.
Exactly.
Anyway, so the whole point of your company is that you guys feel that you have developed something that is analogous to these iconic industrial processes that unlocked these huge industries. So what was sort of the insight that you guys had that led you to start Biosphere?
Yeah, I mean, prior to this, I was running a venture fund called Mars Bio. I'm still a GP there. But at that time, I was looking at a lot of companies in biotech and in biomanufacturing, a lot of product companies in particular. So these are companies that had invented some new product that was made from cells or from microbes, and going after industries like food and nutrition, advanced materials, energy, some medical stuff as well. So it was clear that there was a lot of innovation happening. These tools to engineer genetic code and make new products were kind of getting disseminated out into the world. And many people were innovating. Many people were talking to customers and sort of getting some traction with folks who wanted to buy these products. You have some, say, new engineered protein that could be used in food or something. So they actually were finding traction from a commercial perspective. But what was really challenging was, especially in cases where they were going up against some incumbent product, and even if you're just going into any sort of CPG or consumer industry, price is kind of king. It's really tough to launch a product that is substantially more expensive than whatever its alternative may be, unless it has some insane value proposition. So,
and if it's commodity, there's really no value proposition.
I mean, and at that time, sure, people were saying, "Oh, well, it's more sustainable or something," but that really wasn't enough to get these things sold. If the price
not if it costs 10 times as much,
exactly,
or even twice as much.
And a lot of that price was driven by the cost of manufacturing, and a lot of these innovators had sort of put off the idea of manufacturing and said, hey, we're just going to innovate on this new product and it's going to be so exciting and sexy that manufacturing will figure itself out. Maybe there's other industries where that works in. The sort of manufacturing puzzle is slightly more solved, but definitely in biomanufacturing, that's not the case. So I was seeing all of these seemingly interesting products run into this brick wall of scaled manufacturing and realizing that, the product development, actually, that's not the challenge or the problem. The manufacturing is the problem. So wanted to try to work on this problem, and I, spent probably about a year while at Mars Bio looking for a company that kind of fit that paradigm or that narrative, focused solely on the manufacturing, and in particular manufacturing at scale. Didn't find it. So met my co-founder, and he and I just kind of got to talking about what can we do in this space. And we thought deeply about, well, why is biomanufacturing so expensive? What is driving this? What are some potential technology levers that can make a difference? And, what has changed? What's different today than people had maybe 5 or 10 years ago? Like, what has changed that we can actually apply to this market? And so we really focused in on sterile design as a key constraint around these facilities. So in biomanufacturing, you basically only want your biology of interest to grow. You don't want anything else to grow in your facility, really.
No contaminants.
No contaminants. You want to just grow your one bug. And a lot of times those bugs are engineered and they're really sensitive, so you got to kind of protect them. So that's very different than chemicals manufacturing or hardware manufacturing. You don't really care about sterile conditions in hardware manufacturing. It's totally fine if there's lots of microbes around. It's not a big deal. So this is a very unique constraint of biomanufacturing. And people have tried to solve it in a few ways, but it's still a major problem and a major cost driver. That's kind of what we found. So we wanted to focus on that as like the key issue.
And so how was that problem addressed previously, and how are you guys thinking about addressing that problem?
Yeah, previously, it was addressed using basically high pressure, super hot steam.
Kill anything that
Just
happened to be
burn
living
it
on
with
the
fire,
inside of the
basically.
vat. Okay.
Yeah, just fucking burn it with fire. Go hard as possible, without any regard for, any sort of mediation there. Just going hard with high pressure, hot steam.
Okay.
And this is how the vast majority, pretty much all large scale biomanufacturing plants use high pressure steam. And that requires massive steam boilers, which consume a lot of energy, electricity or natural gas, miles and miles of precision welded steam piping to every single port and valve in these systems. So if you look at a picture of these steam sterilized systems, it's just kind of a rat's nest of pipes, each of which has to be kind of custom installed and inspected and traced. And then the reactors themselves have to be constructed out of a particular kind of steel, be very thick, because you're filling these with high pressure steam, holding them for a number of hours, and then cycling on them up and down to temperature, hundreds or thousands of times over their lifetime.
Right.
So it's a very harsh process.
Okay.
Yeah.
So does it work though? Does it get rid of the contaminants?
It's not perfect.
Okay.
There pretty much anybody who runs one of these facilities complains about contamination, and contamination does occur. As in, there's certain kinds of microbes or there's certain kinds of contaminants that maybe are more prevalent than others, but it's not perfect. It's kind of the best that we have today.
And my understanding, correct me if I'm wrong, is that the contamination is like a particularly insidious problem, because if you go back to that beer analogy and you imagine like a big old beer vat, it's not what you guys are using or what other biomanufacturers are using, but something of a similar sort of scale. You put the ingredients in there, and the biomanufacturing process is not something that takes like a few hours. It can be like a multi-week process. And if you just have a little bit of a contaminant in there, it may, multiply and grow over time, but you don't even know that you're contaminated until maybe week 3. And so you've lost a whole entire batch, and you've lost a whole entire month of grow. So you really got to make sure it's sterile, and it's not like something you can immediately sort of sense and rectify. Is that more or less correct? Or
totally. Totally. Yeah. I mean, I think,
so you really got to make sure that it's sterile. Were you going to say something, Sam? Sorry.
I wanted to ask a little bit of a clarifying question, because you had mentioned before that for specific products, it's not the product development that's the issue. It's like the scale manufacturing that is, and you've identified that the sterilization problem is part and parcel and probably core to the scaling problem. Is it correct to infer that there are some products where contamination matters less? Because it sounds to me like there is a pipeline of products that technically could be, available and produced this way, but they're not because scaled manufacturing is not available. However, it sounds like there's other products that are made this way that don't suffer the same problem.
Yeah. If you thought about a spectrum of products, there are ones that are much more sensitive to contamination and ones that may be less. I mean, the obvious sort of answer is ones that have to go into the food supply or cosmetics or certainly drugs, because you have that sort of regulatory compliance aspect where you don't want anything else in your product. On the other side of the spectrum, you could imagine fuels or plastics or like industrial products that maybe wouldn't, at least from an end product perspective, care that much. But with regards to the biology, I think that's the other aspect to consider. So if you have these fermentations, these biomanufacturing campaigns, they vary in length. Sometimes they can be a week long. Sometimes maybe they're only a day long. Sometimes maybe they're only a few hours long. The longer you go, the probably the riskier it is to have a contaminant. And often the costlier it can be to sort of lose all that time on the machine. But the big challenge is that if you have something that's out competing your primary organism, the productivity goes way down as well. So even if you're making a bioplastic and maybe you can kind of run semi-sterile, you don't really care what's in there, your productivity is probably going to go way down with the assumption that this sort of adventitious organism outcompetes your organism that you actually want to grow.
I see. And so I can imagine that what you're working on at Biosphere is first and foremost the hardware innovation. There's obviously probably some software components to that, but in addition to that, it sounds like a lot of process engineering optimization. Would that be correct?
Mm-hmm. Yeah. The sort of soul or the starting point for us is using UV to sterilize instead of these other methodologies. And that sort of opens up a lot of different avenues for exploration, redesign of the reactor, process engineering, all that kind of stuff.
So the UV instead of steam, no more steam. And I guess plenty of advantages to using UV to sterilize. How come that isn't something that people were doing already? Because, I mean, it's somewhat known that you can sterilize things with UV. I think you can buy like UV phone sterilizers and stuff.
Yeah. I mean, I will say when people hear the idea, they're sort of like, well, that seems obvious, which I don't think is a bad thing.
No, not at all.
And I will say also that sort of the why now answer as well is that UV technology has come a long way in the last 10 years. In particular, during COVID, there was a lot of innovation and investment in UV technology to sterilize surfaces and sterilize hospitals and stuff like that. Particularly UVC, which is the sort of wavelength of UV that we use that is safer, but also really good at killing microbes. So there was a lot of innovation that kind of happened over the last few years that supported the process that we've taken on. But yeah, one of the reasons people haven't done it, I guess, is it is a very risk-averse industry in general. So you see this in a lot of places in biology where there is some black magic, and people follow a particular protocol. And a lot of times they don't know why they follow that protocol. They just do it because it worked, for some grad student 10 years ago, and they keep doing it. And it is because biology is so complex. It's not, it's not a human-built system. It's a, sort of this alien system that evolved over 4 billion years. It's insanely complicated. So there's a lot of black magic around biology because we don't really understand it in a lot of ways. So I think when it comes to biomanufacturing and worrying about contamination, there's also some black magic too. It's like there are traditions, there are standards, there's ways of doing things that have worked in the past, and if it ain't broke, don't fix it. So there's a little bit of that mentality.
Yeah, and I would also imagine if someone has spent tens of millions building a big old steam system, they're not going to want to throw that out the window either.
For sure. Yeah. So I think there's also that aspect, which is that there's infrastructure that exists today that will still be steam in 10, 20 years if it's still operating. Like the expectation isn't that existing infrastructure would be retrofitted. Because, if you can sort of, again, retain those facilities, operating them for a number of years, and it's already sort of fully depreciated, then you might want to just keep using those production assets. That's totally fine.
And so with this new tech, this UV sterilization and all the potential unlocks that it gives you, what do you think? Obviously, it probably varies product to product, but how do you think that the manufacturing cost will decrease? Is it like, percentage points? Is it order of magnitudes? What's kind of like your grand epic vision for how much biomanufacturing this will unlock?
Yeah, I mean, I think the goal at scale is to try to reduce costs by like 10x. And it does depend a lot on the product, and it depends a lot on the scale. So obviously, the bigger your facility, the sort of better you're doing in terms of your process economics. And then some products have particular challenges in terms of, well, how much product is made in a given liter of broth? How do you process it after the broth is made, the downstream processing? So there's a lot of nuance from one product to the next in terms of, value and how much savings UV can allow for. But I think UV opens up this universe of really redesigning bioreactors in a new way, thinking deeply about how those integrate with all the other systems in the plant. And then, in addition to all this, sort of adding the layer on of modern process control, automation, sort of building a 21st century company in this space, which has some value as well, I think.
That's interesting. I actually have a question or a few questions about how your technology integrates with quality control specifically, or maybe makes it better. Because you had mentioned earlier that a lot of the time you don't even know that your batch is contaminated until 3 weeks later. And so I guess my first question is, how do you consider that with what you're building? And then the follow-up would be, is there any new technology on the QC front that makes it easier for people to detect smaller quantities of what it is that could be a contaminant? I'm assuming it's qPCR related, but maybe it's beyond that.
Yeah. So depending on the length of your process, normally you find out pretty quick that it's contaminated, and you can just tell by something like a visual inspection, where you and I have worked in labs before, so you can tell when something's contaminated. It's pretty obvious, right? If your flask is contaminated, it's all cloudy and disgusting. So contamination, when it happens at, often it happens at a very noticeable level over the course of like 2, 3, 4 days, depending on how long that fermentation is. But I think the detection of contaminants or sort of real-time monitoring for analytes and stuff like that, I think is really interesting. It's not something, it's done today quite a lot at the small scale. So if you have a small bioreactor, say at the bench scale, and you're testing out different strains, you're testing different conditions, there's a fair bit of sensing that goes into those reactors, a fair bit of sort of collecting of data about how your process is going, because they sort of classify that as process development. You're developing your process. But once you actually scale up, a lot of that stuff kind of falls away, because effectively you have, and I'm not saying this is justified, this sort of is how it works now. You have a recipe, and you ultimately take it up to large scale, and then you hand it to a non-biologist and say, run this recipe day in and day out for the next 20 years. Yeah. So when we've talked to people who are at large scale about having, hey, our reactors can have better sensing of, analytes, we can have metabolic sensors, and we can even have protein-based sensors in them because they don't get destroyed by steam. Would you want to learn about all these analytes? They're like, no, not really.
So basically you're saying like miso soup, bad. Bone broth, good. That's generally.
Yeah.
And tweak until miso soup turns into bone broth, basically.
Yeah. I mean, like I said, at scale, usually these processes are super well defined, so there isn't really a need for as much process monitoring. That said, I think, this is sort of the legacy of way of thinking where, hey, you built this facility 20, 30 years ago, you're not going to go in and install new sensing on it. But if we are building a new facility, I think we can think more deeply about what would you want to know in real time about your process that could actually provide value. Maybe there are ways to optimize on the margins. Like maybe you're not going to double your production in a given tank, but maybe you can, optimize it by 5 or 10% or something with better sensing.
That's really interesting.
Wow. So going back to that big 10x improvement that you hypothesized, I'm sure there are some things that you probably think should be made with biomanufacturing, but currently are not because it's too expensive. And like, if we could achieve this 10x improvement, we would have an abundance of, some specific goods. Are there any things that come to mind as kind of like obvious candidates for being made with biomanufacturing if you can unlock that huge cost decrease?
Yeah, I mean, there's a whole range. I think an area that we're pretty interested in is natural colorants. And I think
like methylene blue, like
yeah, exactly. I mean, like that, but but bio-based equivalents, basically.
You mean like food, like red dyes or things for food,
exactly,
and that sort of thing?
Yeah, and I think there's
clothing, maybe
potentially textiles too. Yeah, there's actually probably at least a dozen companies working on colorants that are derived from fermentation or from biomanufacturing. Some of them are. Actually, many of them are naturally produced by a microbe. Someone found a microbe out in nature that is totally red or something. So I I think, and in particular in food nutrition and maybe cosmetics, that's interesting because people kind of care where their colors are coming from. Textiles, I think, is a little harder. Do you really care? Maybe eventually people will care more about how their clothes are dyed.
Right. No, I mean, there's so much discourse around like, oh, we got to get this red dye out of the food supply, or yellow dye number 6, whatever.
Right.
And so
especially now, I think there's kind of renewed interest in that, and there is some evidence that there are some negative health effects to some of these dyes. So that's one example. I think that's maybe.
And is it possible to do this now? It's just too expensive.
Yep.
Okay.
Yep.
So it's really just a matter of bringing the cost down, and then you can do it.
Exactly. So yeah, I mean, we have some programs in house working on new food colorants, and we're talking to a couple of CPG companies about them. Who have chips or cookies or whatever. Of course, the challenge is they don't want to spend more than a fraction of a penny on a new food dye or something more than maybe what they're already paying. But you also have this kind of regulatory environment that's changing too. It's like if Red 40 is whatever it is going to get banned, we have to find alternatives. Mm-hmm. So I think that's kind of an interesting place.
So food dyes, number one.
Yeah. Yeah. And I think also sweeteners are also kind of interesting if we're like staying on the food topic. So there are a number of protein-based sweeteners. So these are 0-calorie sweeteners that give you the sensation of sugar but are not sugar.
Not like a Splenda or something, or
yeah. Basically, a safer, healthier alternative to Splenda. That's a protein. I think if you talk more about kind of the long tail of commodity products, there's a lot of interesting stuff there. I mean, many microbes, you can basically generate protein, like a protein powder from microbes. Yeast or bacteria, and many of them are a complete protein source that has sort of all the essential amino acids. So today, very hard to compete with dairy.
Although whey protein, I got to tell you, whey has gotten so expensive in the last 10 years.
Yeah, I mean, especially if you get the good stuff, the grass-fed, premium YouTuber special.
I mean, it's like $75 for a tub now.
Yeah,
when I was in college, it was like 30.
Yeah. It's definitely gone up in price. So
you could theoretically make like a complete protein that has all the amino acids, all the BCAAs, some kind of protein powder, biomanufactured.
made with yeast, for example. So I think that's interesting, bulk protein. And then sort of even further on the commodity trail, plastics. So there are microbes that make polymers, and there's a number of companies working on basically biomanufacturing derived polymers for water bottles, all sorts of different use cases. And generally, I think those are pretty exciting. But again, you're competing against petrochemicals, and they're very cheap. Yeah. So,
Sam, were you going to?
Yeah, we've seen a lot of companies over the years that are pitching us on the biomanufacturing of small molecules. And earlier in the conversation, you talked about why I guess it's more interesting to use biomanufacturing for biologics. So for those listening, biologics are like generally proteins or more complex molecules, whereas small molecules are generally made from petrochemicals. Do you see a situation in which maybe with a specific category of small molecules, it becomes kind of like this part of this commodity basket of products down the road? Or do you think that that's hard to justify?
Yeah, I mean, I think... peptides are interesting because if we kind of shift more to talk about drugs in general, but there's obviously other uses for peptides. But peptides are kind of interesting because they're a little bit in between. You can make a peptide, which is just a short protein, short amino acid sequence. You can make it using chemistry, roughly the same way you'd make a small molecule. But you can also make it with biology. So, and then you can kind of use the GLP-1, the sort of Ozempic use case, as an interesting thing here because that is a peptide, and it is made using biomanufacturing. So
they're doing it now currently with biomanufacturing.
They're doing biomanufacturing now. So they're growing it up in big tanks. I think it's made by a yeast. So they've engineered a yeast to make Ozempic, and they grow it in big tanks, and then they have to do some processing on it afterwards. There's some complexities there. But they've basically said, hey, this is a more cost-effective way to make a peptide, even though we could make it chemically synthesized. So could you imagine a future where making small molecules using biomanufacturing does make sense, even though there is a equivalent chemical way to do it? Potentially.
I think maybe for some of these more naturally occurring compounds that have a lot of chiral centers, that have all this weird stereochemistry. I've seen that oftentimes those are really hard to synthesize from scratch.
Yeah.
And so you need some kind of semi-synthetic starting material.
Right.
I think maybe there's something there.
Yeah. I mean, we've maybe in the past talked about this company that was trying to do psilocybin using fermentation.
Right. Yeah,
and I feel like you've looked at a few of those. Because, we have this fungal host and it's sort of already got maybe some of the machinery to make this, and it's better than driving it from actual mushrooms. But the economics are pretty hard still, probably.
Sure. Well, especially given that there's no legal market for psilocybin.
Oh, yeah.
We need more.
Right. We need to sell it. We need more of this
we're
thing
not
that
allowed
no one's
to
buying.
make it, but we're going to make it.
Yeah.
I forgot about that.
Yeah. Picks and shovels for a non-existent industry. That's always, we love those types of companies.
Critical. It's the next level version of the Russ Hanneman. You want to be pre-revenue. You want to be pre-legal market.
Yeah, you want to be pre-market. Yeah, that's awesome.
I was going to ask before I forget, where on the subject of products that can be made here, you're talking about protein. Where does like lab-grown meats fall into all of this? Is that a biomanufactured product?
Yeah.
When you hear people talking about growing like a steak in a vat, not like Beyond Meat, but I'm sure you've heard of the people talking about, we could literally grow like a steak without a cow.
Yeah, so I think that's definitely in the same category. And, one nuance there is that today, Biosphere, we're primarily working with microbial systems, so bacteria and yeast. Most of the lab-grown meat strategies are around cell culture or growing beef or chicken or pork or whatever, which is a little bit different, but it also still happens in bioreactors, and growing those types of cell types is something that we do want to do in the future. There's also a little bit of a stratification required between, making a steak that has some sort of 3D printed component to it, where it's got,
Marbling.
structure and
Mm-hmm.
For the most part, yeah, exactly. So those cells had to come from somewhere to sort of then put into that structure. Not sure how those are produced, probably in little flasks or little dishes. Right. For the most part, what's coming out of a bioreactor is a slurry. So you could imagine something more like, chicken nugget, ground beef, whatever, et cetera. And all of this stuff is theoretically possible. It is just about cost and efficiency. So if you look at, there have been a number of analyses of the costs associated with lab-grown meat, and definitely healthy skepticism. And I think you've seen that there was, a boom of investment during the zero interest rate phenomenon era. And many of those companies have come down to earth because there's sort of the realization that, if a nugget costs $100, there's just no way that's going to fly. I do think probably in the next 5-ish years, the costs are going to come down, and it's going to, things will continue to get approved and kind of rolled out to the market.
I suspect. It seems to be enough of a threat that Ron DeSantis is banning lab-grown steaks from Florida. So
yeah,
they must think it's coming.
Yeah. It's great. I just love the culture war stuff is fun. And it is just, it's just sort of, it is culture war stuff. It's not really based on any reality, which is it's fine.
You had to win a few points.
Yeah.
I was going to ask so these are we just talked about a bunch of examples of products that could be made in this way. From a business perspective, with Biosphere specifically, is the vision to be a manufacturer of hardware that is sold to other biomanufacturing facilities? Is it for you guys to run your own biomanufacturing facilities and you just sort of make whatever products companies want you to make? Or is it sort of like a vertically integrated grand vision where you guys are going to own the IP on the bioreactors, you're going to own these massive warehouses filled with these bioreactors, and you're going to be making stuff that you want to make and selling, or probably some combination of all those three? How do you guys see yourselves evolving in terms of the type of business?
Yeah, it's a great question. I think it's always a challenge when you sort of invent a new tool. How do you go to market with that tool in an effective way, and what's sort of the long-term vision for that tool? So one of our things we always say at Biosphere is that we want every great bioproduct to be made on a Biosphere reactor or a UV reactor. That's the goal. And there are many paths to get there, most of which you listed. So today we are building and operating these infrastructure ourselves and partnering with product companies to support them as they scale. So right now we have these operational reactors, and we're working with other companies who have engineered a strain to produce a product. They're coming to us, and we're working together with them to scale up these products. So this is sort of a contract manufacturing type arrangement. As we continue to scale, our goal is to sort of get up towards commercial scale in the next 1.5 to 2 years. Our economics start to look really good. We're able to prove out the value of these systems. From there, we have a lot of options available to us, including working together with these product companies to support them in building infrastructure. Maybe they want a dedicated line for their product. So that could be either a sort of joint development construction project, or it could be licensing the technology if we want to have some, very nice high margin revenue. So we can imagine licensing UV reactors to a number of different partners who want to implement them in their facilities. But I think even longer term, there's a lot of creative avenues you can go with this, including sort of very small, modular, decentralized reactor systems to produce products all around the world. That's one idea. I think
how small and decentralized? Are we talking like in every person's kitchen, there's like a little bioreactor sitting there? Are we talking?
It's theoretically possible. Okay. Yeah, it's theoretically possible. Now, how much product would that reactor produce for a given amount of, for every day? And you have to think creatively about feedstocks. Like maybe you would have to use atmospheric CO2 instead of sugar or something, which is possible. Mm-hmm. So I think if we ever want to have the Star Trek replicator vision, bioreactors are probably the best way to do it.
That's the way. Okay.
Yeah. So, but bioreactors on Mars, like that should be a thing. Bioreactors on a space station, that should be a thing. So there's sort of that end of things, which is maybe a little bit more sci-fi and speculative. I think for the majority of products that Americans use every day, you probably want more of a centralized approach. You have something like an Amazon distribution center, one in every urban hub or whatever, that has a lot of great economies of scale. And you can probably run multiple products in those facilities.
Locally fermented.
Yeah. I mean, somewhat locally, I could imagine just kind of each region has its own, mega site to do this biomanufacturing of a number of different ingredients. And then I guess with relation to sort of product strategy at the company, for some of the commodity products, it's likely that vertical integration would be the best solution. If we're going to make a fuel or a plastic, sort of having multiple partners in the equation is definitely much more challenging. Just from a cost perspective. And also if these products are slightly less differentiated, it's kind of easier for us to make it ourselves. But of course that requires, a lot more knowledge on sort of the distribution and sales side into these particular markets if we're not counting on a partner to do that. So I think that's kind of, the 5 to 10 year vision is continuing to partner with great bioproduct partners product companies who want to scale on our platform, doing joint development of infrastructure, potentially through licensing the technology, and then vertical integration into some of our wholly owned products in the more commodity type space.
Gotcha. And at what point along that timeline are you now? Because you guys got started, 2 years ago, I think, 2.5. And so at this point, you have a warehouse. How much is going on in that warehouse? Like what sort of exciting milestones have you achieved?
Yeah. So, I mean, the first phase of the company was really, we had this idea that you could build a UV sterilized bioreactor. And, on day one, it was just an idea. So we basically filed some IP before we even went out and talked to anybody, locked down basically UV bioreactors, and then raised some capital from some great investors, Lower Carbon and Founders Fund primarily. And yourself.
That's right.
Yep. Appreciate it. Brom.
The third item on the third line item.
Yeah. Right below Founders Fund. Yeah. If I recall, Peter Thiel told you about the deal. You guys were.
That's right. Yeah.
You're in a hot tub or something.
Something like that.
Yeah. So we got started basically and spent the first,
It's actually a bioreactor.
Okay.
Oh my God. Terrible joke.
The first phase of the company was really, reducing this idea to practice. It's like we knew that UV can kill microbes. We knew that. We saw it as an engineering challenge to actually build a system, So the first phase of the company, basically the first 1.5 to 2 years, was iterating through hundreds of designs of these bioreactors, figuring out what worked, getting them fully operational and kind of running in our lab. And now we are basically about to launch our slightly larger scale system, which is about 3 or 4 feet tall. It's a pilot reactor. So you sort of have bench scale, pilot, demonstration, and then commercial, or sort of these standard phases of size and scale. So we're launching this pilot system and designing bigger systems. So over the course of the coming year or so, we'll basically design a sort of small commercial line that'll have both the reactor as well as all the downstream processing. So you can go from strain to product, which we're hoping to have operational, maybe end of next year or something like that.
All right. So things are moving.
It's exciting.
Do you have any? I have more questions, but if you.
I think because I come from the small molecule drug world, a lot of my questions have to do with my curiosity about what you think of certain things. So maybe less about the company, but at the very beginning of the podcast, you were talking about the definition of biotechnology and how, it's lent itself well to the drug development world. How do you think about and rationalize how the term biotech has been co-opted by just like everyone that's doing drug development and therapeutics more broadly? Because technically, a lot of these companies are not really using a biotechnology directly.
That's a good point.
It's something that I actually think about like all the time.
Yeah, that is interesting. I mean,
what you're doing is more biotech than most drug discovery.
Yeah.
Exactly.
Yeah, that's why I always try to use biopharma when I'm talking about, drugs that are derived from biomanufacturing.
But even still, like for example, if I talk to a generalist investor or like a finance person, they'll call a small molecule drug discovery company a biotech or biopharma,
Yeah.
So I'm curious to know what you think about that.
Yeah, I mean, I haven't thought too much about the nomenclature. I can totally understand why that would annoy you.
Someone that is like insanely ontological.
Yeah, I mean, the only thing that I've been annoyed about lately, which is not news to anyone, is the tech bio versus biotech.
Oh,
which is
God.
even more
That's
cringe.
worse.
Yeah.
Oh, my
yeah.
God.
It's bio, but with software margins.
Yeah. So I don't know. I mean, I guess, would you say that these people need to be corrected and we need to have more standardization around our language for these different categories?
Sometimes I think about that because I do think that it kind of generalizes the entire ecosystem to the point where investors that are more generalist may make assumptions about cost, may make assumptions about value. And to me,
assumptions about regulatory scrutiny.
Right.
Like what he's doing doesn't require FDA approval or trials.
So I do think it there was a paper in the neurotech space that, experts came together on and developed and corrected an ontology of what neurotech means in BCI. I think we need an equivalent for biotech.
I think that is a good idea. And I'll occasionally use, I think I was referring to med device as med tech, which apparently they don't like anymore.
Why?
Really?
I don't know.
That's, that's my first time
maybe this was just the particular person I was talking to, but I think, maybe we need a market map of nomenclature for this kind of stuff. And I mean, we have the same thing in biomanufacturing, which is that up until maybe a couple years ago, a lot of people called it synthetic biology. Synbio was sort of the buzzword. But synbio is also synbio and biotech are kind of equivalent, except synbio sort of was meant to have this air of more computational and maybe AI.
Now it's tech bio.
Yeah, I mean, so we had synthetic biology for a while. Then we sort of dropped it a couple of years ago. And I mean, the way we call it, most of our products are industrial biotech products. So non-biopharma is another way to say it. So it's like everything but biopharma is sort of where we're at today. But
programmable biology now.
I mean, yeah, I like that too. But industrial biotech also sounds like, we're only making chemicals. We're also, making food ingredients and lots of other products. It's not just for industry per se. But yeah, the nomenclature thing's kind of interesting.
I think it somehow like indirectly negatively influences the entire sector just because the way later stage investors think about it is convoluted. But maybe I'm overthinking things like usual, but I was just very curious to hear what you had to say.
Yeah, no, I definitely understand that. So if everybody gets labeled biotech, that has certain, that implies that, it is a biologic drug and it's going to take this long to develop and it's this costly and these are the regulatory agencies that are associated with that. So that is kind of a problem, especially for a startup, I'd imagine. Yeah.
Interesting. Do you have any, like for people listening, and I guess myself too, any book recommendations on biotech more generally that could help someone orient themselves instead of waiting for this like ontological white paper of what biotech means?
I mean, I think, I don't recall what the book is called, but The History of Genentech, there's a really fascinating book on that.
I think it's The Gene.
The Gene, yeah. I mean, yeah, that's right. that's really excellent. And I think it's, enough of a page turner that a regular person would just be into it. So it's actually quite an interesting story, especially I think there was a lot of debate around the ethics of recombinant DNA and gene engineering at that time, in sort of 70s roughly. And it's kind of interesting to look back on that and see some parallels to today. Like there are probably a lot of debates that we should be having that are kind of in a similar category. So I found that pretty fascinating.
And what's your favorite book on industrial process engineering? I know in the Biosphere warehouse you have the photos going up the stairs of all of the different iconic labs and hardware guys.
Yeah, I mean we have a picture of BASF, which is a big chemicals company. This plant called Ludwigshafen, which was like the first
Ludwigshafen. What does that mean in German?
I think it maybe is the location. I'm not sure exactly,
okay.
But it was the first integrated chemical refinery where they had sort of all the steps on site. Basically built in the 1800s, I believe. And then we have this guy named Taiichi Ohno who invented the Toyota method of manufacturing, which I also find really fascinating. There's a few other great pictures there. But yeah, in terms of books specifically on industrial biotech, not really too many. I would say I read more general information from parallel industries that can apply. I'm trying to not get too in the weeds on what has been in industrial biotech.
Cross-pollination is good. Cross-disciplinarity is good.
Yeah.
So you mentioned earlier that when you guys raised money for biotech, in addition to my money, you also raised from Founders Fund and Lower Carbon Capital. And I think it's actually quite interesting because in my view, and I think probably the view of many other people in the VC world, those are two funds that have a very different kind of like set of values and aesthetics. Obviously, Lower Carbon is very much like, we got to stop climate change. And then Founders Fund, maybe climate change is real. We're not sure. At least that's Peter's. He's said that on a number of podcasts. However, both of them believe that biomanufacturing is something that is important, and I think it's kind of interesting that this is like a one element, at least, of a what you might call a green technology that even people that don't necessarily think that climate change is the highest priority or concern still view as very important. So how do you it seems like this is a thing that you can very easily sell to both like the American Dynamism crowd and the we need to save the world from climate change crowd. Can you give the short pitches for both of those crowds?
Yeah.
Because I think that's kind of an interesting thing.
Yeah, it was really interesting. I mean, it is very interesting to have both Lower Carbon and Founders Fund on the cap table because, you're right. They kind of have very different aesthetics and vibes and, seemingly mandates. But
and I like both of them for the record.
Yeah, they're both really excellent investors and they've been hugely supportive. And you're right about these sort of various narratives that you can tell about a company like ours. And I think we definitely have to do our best to avoid the temptation of just kind of going whichever way the wind blows.
Of course.
And I think obviously in this day and age, there is that temptation to really focus on sort of the defense manufacturing aspect of it. But I think fundamentally, biology is both a sustainable technology and a resilient technology. And the sort of flexibility and capability of biology is really unparalleled to turn simple feedstocks into such a wide range of critical products. And those products might be critical from a sustainability perspective. They might be critical from a trade perspective or from a military perspective. So I think the fundamental is that this is an excellent way to leverage the natural resources that we have to develop high quality products for a wide range of different consumers and government stakeholders. Yes, it happens to be a sustainable technology, but it's also the most advanced technology in the known universe. So
it's true. Obviously it's sustainable. It's carbon negative, right? Because it literally, some of these, at least I imagine some of these processes suck CO2 out of the atmosphere, at least sometimes.
I mean, I mentioned there's a lot of projects that are working on using non-sugar feedstocks, including CO2, methane, stuff like that. So there's crazy microbes that will eat gas, basically.
Yeah. So it's potentially carbon negative and also potentially a 10x cheaper way to manufacture things that might be critical to the nation's livelihood, whether from a defense perspective or just hey, protein's getting expensive and it's in the national interest to make sure that everyone, even the poorest person in America, has 1 gram of protein per kilogram of body weight, to maximize the gains.
Yeah. I mean, vitamins are a good example where it's like many vitamins today are made using biomanufacturing. And in the past, these vitamins were derived from, either animals or plants, or, it was a much more challenging process to isolate these vitamins. You'd need to, use kilograms or hundreds of kilograms of biomass to get 1 gram of vitamin. So now we have, now this is able to be done using microbes that naturally produce these vitamins. So it's sort of a sustainable technology to make these vitamins that go into our food and animals' food. But the sort of supply chain aspect of it is, well, unfortunately, we ended up outsourcing the manufacturing of all these vitamins to China over the course of the last 20 years. So yes, they're made with this sustainable technology, but they're also all made in China and imported today. So
which is not a sustainable thing, generally.
Right.
Yeah.
So if we ever end up in an instance where that supply is cut off, we're kind of in dire straits, and there's really no reason why we shouldn't make that here, again, in a sustainable way. We have the resources to do so, but similar to all of these other outsourced to China manufacturing stories, that was also sent overseas.
That makes sense. And you mentioned defense. If you're not allowed to talk about it, I'll edit it out. But can you talk about the explosives?
Yeah. Well, we're not doing explosives.
Okay.
Yeah. So, but I can talk about our project with the DoD at a high level. So we currently have a program with the DoD focused around oils. Yeah, both for food and industrial applications. So there's certain kinds of microbes that make different types of oils, and you can really tune them in a lot of different ways in terms of their behavior and properties. So it's sort of a bio platform for producing lots of different types of oils for different applications. So we have
like motor oil or like cooking oil or both.
The sort of leading edge that DoD is most interested in is for food and nutrition applications. So we're working with Combat Feeding, which is the name of the agency that basically makes all the food or designs the food for soldiers, and then ultimately partners with folks who produce that food, MREs, whatever. They're very interested in higher performance fats as well as fats and oils that are made in the U.S. and not imported. So today, a lot of them are coming from overseas, especially the palm oil and stuff like that. Oh. So it's sort of a supply chain strategy. And then we have some other stuff coming down the line that they're also interested in that is not as food related.
What was the explosives thing that I remember?
Well, they're biology is good at making some things and not good at making other things. So typically, biology is not good at making things that go boom. Okay. Because very few biological systems blow up. Right. There's not a lot of, granted, I guess we make methane and that's flammable, right. Like cow farts you could light on fire. So, so maybe I take it back. But anyway, so generally speaking, a lot of these energetics and explosives, probably fine to make them with petrochemicals or whatever the current state is. But there are certain precursors that can be made using biology. And those they're interesting for various reasons. We're looking into them, but we're not currently running any programs in that space.
It's pretty interesting because so much of what intelligence agencies and the DEA and stuff will do is they'll monitor who's buying these precursors. Mm-hmm. Or I guess this would be more ATF, right? But they monitor who's buying these precursors. But if someone figured out how to biomanufacture an explosive, that would be a very hard thing to detect,
Yeah.
Giving people ideas.
Yeah. Well, ask ChatGPT how to engineer.
Yeah. Well, there's a company that's using biomanufacturing to make opiates and alternatives. They're called Anthea. So they're making fermentation, biomanufacturing derived opiates. But if you were really savvy and you could engineer a cell to make stuff, I would probably focus on the drugs before the explosives. But that's just me.
Much more practical.
Yeah, and you just sip on that thing. You don't even need to purify it. You know what I mean?
Right. The broth, the opiate broth.
Yeah.
Oh my god. My god.
That's so funny. Sam, you want to chime in on this?
Not really.
Okay.
I don't know if I have any good questions to ask. I'm assuming that they're trying to kind of brew a collection of opioids and not just one specific opioid.
I believe that's true. Yeah, I believe that's true. And obviously, opiates are originally derived from plants. So they probably took some of the pathways from the poppy and put them into yeast. And that's maybe a more scalable way to produce these compounds. I don't know too much about the specific compounds they're making. But I did want to highlight one thing, which is sort of relevant to biopharma, is that really the only innovation in bioreactor design is the single-use system. So pharma invented these bioreactors that you throw away every time you use them. So their solve for this sterility contamination issue was, I'm going to build a bioreactor where you just grow up all your cells in a big bag that's been pre-sterilized and then toss the bag afterwards.
Can't they just
That's
like
what they
make
use
a?
now.
That's very commonly used for biologics manufacturing.
I'm curious, like why they thought couldn't they just make like a giant autoclave? You know?
Yeah, I mean, they basically, that's the steam system, is basically a giant autoclave.
Okay, that's right.
But especially for smaller batch drugs, I think these single-use systems have limitations on how big they can get. So for sure, cell therapies, I mean, those are all, you imagine just a bunch of consumables thrown away every time. And maybe up to something like, I don't want to get quoted, but 1,000 or 2,000 liters is probably the biggest single-use system that these companies use. For Ozempic, I think they probably use steam sterilized because the volumes are really big, I would imagine. But it is interesting to look at that as maybe the only other innovation in bioreactor technology that's happened in the last couple of decades is single-use systems for biopharma, trying to solve the same problem. Basically, it's like, we don't like steam. We want to reduce contamination. We're not cost sensitive, so we're willing to throw away the whole thing every time. But it really doesn't work for any product that's less than, the price of a drug, because it's quite costly.
This is going to sound like a silly question, but could you use a bioreactor to make a cell therapy specifically?
Yeah. I don't really. Basically, cell therapies, I think, are made in bioreactors.
Okay,
they're
I have no
kind
idea
of equivalent.
how they're made.
Yeah.
That means growing a new cell or a bunch of cells that are infused.
Yeah. If you need to propagate them, if it's not just, hey, I pulled out a bunch of T cells from someone and then engineered them and they just, I'm not really sure exactly what the sort of hardware mechanism is there. But if you ever needed to propagate them, just like if you're trying to grow up a CHO cell, then something like a bioreactor would be needed where you're managing the temperature and the pH and the oxygen and all that kind of stuff.
I know about the manufacturing and the product development, if you will, up until the point of propagation. So I'm curious because one of the most cited reasons for being bearish on cell therapy today is the COGS associated with manufacturing and scaling. And so I think there are some, and I'm not an expert in this at all, but like some interesting ways to solve for this that are happening pre-propagation, if you will. And I don't know exactly what those are, but it seems like an opportunity.
Yeah, I mean, one reason that we didn't go into biopharma or have not yet gone there is that the regulatory costs are just such a big part of the whole equation. So if we're not solving that piece of the puzzle, we're really solving more the infrastructure, the operations, all that kind of stuff. The regulatory overhead, the cost of that is still so substantial that, what kind of difference can we make? I think for cell therapy, it would be interesting to see, well, yes, it's so expensive, but where are all those costs coming from? It's probably not the hardware. It is probably regulatory overhead. Yeah. But for sure, our system should work well for drugs as well. We just probably have to find the right niche to sort of get a foothold there.
I suspect, and I'll end it here, but I think what I've heard from individuals is that you can only propagate so far before needing to start again. So when you mentioned single use, I thought of cell therapy as perhaps maybe that's where they're innovating in the best sense. But interesting. Also, just very, very silly question, regulatory costs. Can you break those down for us? Like what exactly are the regulatory costs? Is it consultants? Is it more QC? Is it just basically trying to make it so that it's as pure as possible and purification?
Yeah, I mean, I have limited experience with the GMP in like a clinical context, but my understanding is that it is part of it is basically having all of your equipment, reagents, every single product that goes into your facility compliant, inspected, bought from a specific vendor, tracked, etc. So every single reagent is like, exactly where it came from and it's GMP grade and all this kind of stuff. A whole complicated supply chain. Yeah. And then it's sort of the day-to-day activities of, well, people have to track where every single thing in the facility is going. There's a lot of documentation associated with that, as well as at some point inspectors have to come for example, for us, we're building a new piece of equipment. I'm sure an inspector would have to come figure out some way for us to validate that equipment and say, yes, this can be GMP grade.
Validation.
Yeah.
Yeah.
So it's just a lot of human overhead, paperwork overhead, engaging with regulatory agencies overhead, which is kind of just a whole, it makes sense that it exists, but it's quite a lot of work.
That makes sense.
Yeah. What is your take on not pharmaceutical grade stuff, but the universe of possible engineered probiotics that might be beneficial to wellness and other things? Like I remember you showed me that Z-Biotics thing, which as far as I understand, it's like they specifically engineered this probiotic for the purpose of breaking down alcohol so you don't get a hangover.
Yeah.
And you could make those in your tanks. Do you think there are a lot of useful applications of engineered probiotics, or is it pretty niche?
I think, and you guys would agree with me on this, I'm sure, that the gut is a very interesting place.
Yes, for sure.
And the gut microbiome is super important. So it just seems to flow obviously that interventions there would be very interesting. And whether they're an engineered probiotic and, an engineered gut microbe to do some X thing, or a natural gut microbe that you just don't have enough of, whatever it is, better ways to intervene in the gut seems really important and useful. And to be clear, if you want to make a probiotic or an engineered probiotic, those are all things that we would do, for example. So it doesn't have to be engineered at all. It can be natural. Sure. And there is data, to show that there's certain probiotics that mediate stuff with serotonin. And again, you guys, I'm sure know more about this than I do, but mental health, the sort of gut-brain axis is so important. So anyway, I think more probiotic products, I think are definitely necessary and coming. There's obviously gaps, like if you take a probiotic, does it just frickin' die instantly? Does it actually colonize your gut? Right. A lot of probiotics are kind of bogus because you just eat them and shit them out. Yeah. So I think the engineered probiotic like Z-Biotics is really interesting because, you can really see that it's working. It has a very specific intended effect. Doesn't work for everybody, but, you're like, hey, I'm glad I took this. It actually had an effect, so I'm going to buy it again.
Right.
A lot of other stuff is a little bit harder to sort of capture and define.
It's interesting that they were able to engineer that and then sell it without getting FDA approved.
Yeah,
it's not a new chemical entity, but it's like a new
so they
microbe
got
entity.
they got GRAS, which is generally recognized as safe because there's a lot of precedent for the bug, the organism itself, like that's already out there and very common. And they managed to kind of get through the GRAS pathway saying, hey, we just made it excrete this other enzyme, which is a natural enzyme and stuff like that.
And so the Z-Biotics product, I don't know if we said it or not, but it's basically an enzyme that you drink before a night of drinking so that you don't get a hangover.
It helps process the alcohol so you don't get a hangover.
Yeah, it's a probiotic that has this enzyme inside of it. It's engineered to express this enzyme. So it's a microbe.
Like aldehyde dehydrogenase or something?
That's the one.
Okay.
Yeah.
Wow.
Look at you. I think it's acetaldehyde dehydrogenase, but yeah, basically
there's
that one.
2 or 3 main ones that break down alcohol, I think. That's pretty
so
interesting.
it breaks down a byproduct of alcohol metabolism that causes hangovers.
I want to try it.
Yeah, try it.
Yeah, it's actually quite great. The one time you gave it to me, I definitely should have had a hangover the next day, and I was totally fine. It was incredible.
Yeah.
I forgot to ask. I was going to ask this when we were talking about the lower carbon versus founders fund vibes. What is the current administration's view on biomanufacturing? Are there any efforts in the administration to really push biomanufacturing as sort of like an America first, bring back manufacturing to our soil kind of policy?
Yeah. There are actually a number of efforts ongoing. So there was a recent report that was released by the Senate, led by this Republican from Indiana named Todd Young. And Indiana is a state that has a lot of biomanufacturing. They also have a lot of corn, which is sort of often correlated in the U.S. So he and his whole team and a team of people put together this report talking about biotech as a strategic industry that we need to be investing in. And whenever you talk to anyone sort of within the DoD or within the government talking about sort of future technologies, they list AI, quantum, and biotech as sort of the 3 things they're most focused on. So I do think biotech is a priority for the current administration from a sort of domestic integrity standpoint, as well as, the U.S. should be leading at the frontier of technology, whatever that may be, and we should be leading at biotech, but we're kind of falling behind. So I think it is a strategic priority. Thus far, it has not turned into action yet. So, we have a bunch of programs that we're working on, many which are, potentially going to go ahead, but we haven't seen the administration actually sort of take that action to, say, deploy capital in these industries or deregulate or whatever it may be. So it's definitely a priority. I think it's still primarily focused on biopharma and medicines, but there is some aspect of it that's focused around, building a resilient economy, supply chain, all that kind of stuff.
You can just make a biomanufactured replacement for seed oils. You can get RFK stoked on it, and then
this oil that we're making is a replacement for seed oils that's much healthier. So I just need to call up RFK and get him on
Make
board.
sure you timestamp that and highlight it in the
Yeah.
notes. I wonder how the government is.
We're predicting the future on this podcast.
I was going to say, I wonder how they're defining biotech.
That's a great question.
I'm going to go look after.
Well, yeah. RFK had this tweet that was like, let's see, was it MABA? No, it was something about make American biotech great again or something. So he's thinking about biotech.
He is.
I think definitely from a medicine perspective.
Yeah.
So
and food supply perspective.
Yeah. Yeah.
And if I remember correctly, there was a big biomanufacturing push in the previous administration as well, right? Like under Biden?
Yeah. So that's definitely caused some tension because the Biden administration was also very interested in biotech, but for them, it was certainly more of a climate perspective where, they obviously, spent a lot of money on sustainable technologies, however you define that. So under the Biden administration, there was an executive order that said, hey, we're going to invest $1 billion in biotech for, industrial use, for sustainable use, et cetera. That statement that Biden put out around that was rescinded by an executive order from Trump. Okay. So he said he axed that. Now, that didn't really result in any policy change. It was just like, I'm the new guy. I don't want this to be standing. I'm going to cut it out. So I think now the narrative is getting reframed around domestic security, domestic manufacturing, as opposed to this sort of sustainability and climate thing that was under Biden. But, it is definitely consistent across administrations. I think one advantage that makes it more bipartisan is these states that produce a lot of corn are red states, and corn is the primary feedstock for biotech and biofuels, which are an absolutely massive business. So whichever administration you're dealing with, there's quite a strong cohort of people who are really supportive of biotech in the Midwest in particular.
Biotech is bipartisan.
Yep.
I love it.
Yep.
Any questions from you, Sam, before we wrap this up?
No, I've learned a lot. I really enjoyed hearing all the nuance about biomanufacturing specifically.
Is there anything that you wanted to call out or anything that you were hoping you would get to talk about on the podcast that we failed to ask you? Or
you didn't ask me what I would be doing if I wasn't doing this.
That's true. What if you were?
Okay. What would you be doing if you weren't doing this?
I think, there's a couple areas that I would, if I ever become a billionaire, I would be investing in. I do think broadly consciousness is very sort of interesting to me. I think it's, a really broad topic and maybe it's kind of tacky to say, but thinking about how, I have a fundamental belief that consciousness is a property of the universe as opposed to something that's created by our brains. I would like to invest more in investing in that or seeking out answers there. And as sort of a subheading to that, I'm really interested in cetacean consciousness, like whales and dolphins. Oh. So
what does that word cetacean mean?
Cetacean is the category of animals.
Like the phylum or something?
Yeah.
Okay.
Within you have, orcas and dolphins and whales and stuff like that. And so I do think they're probably just as smart as us, if not smarter. And it seems like we're kind of dropping the ball on not interacting with them.
That's a good point. And what's so crazy is that you would think that now with LLMs, we've basically been able to create instant translation between any language.
Yeah.
and no one has
People
done this.
People
on
are
the
working on
dolphins.
that, and I think something will happen. There will be some sort of breakthrough, I think.
I would hope so, because we've had LLMs for quite a while now. I mean, it's like a few years old, and
Yeah.
I remember I went to this thing like in 2023, and someone was talking about decoding animal speech, and it's been 2 years, and I still can't.
God, that
You
would be
still
so
can't talk to a
wild.
dolphin.
Yeah, I mean, and maybe is it a lack of investment? Is it, I'm not sure what is holding the field back. Is it a lack of training data? I don't know, but it seems like if we're ever going to talk to aliens, we should probably try to figure out how to talk to other mammals first, specifically cetaceans, because I think they're smarter than us and can teach us a lot.
Best for startups.
Yeah.
If you could ask a dolphin one question, what would it be?
Oh man, I think I would probably ask for like a history lesson, to try to figure out if they actually do pass down information about their sort of history and lineage, like about dolphin society, how did it evolve over time, because they basically survived in the oceans and presumably never gone to war. I don't know. True. How are dolphins? I'm sure they fight with each other, and obviously there's all these anecdotes about them
pretty
doing
vicious,
nasty stuff.
from what I understand.
Yeah, but no large scale no dolphin World War II as far as we know, no dolphin nukes as far as we know. So there had to be, I guess they don't have thumbs. I don't know if that's the only excuse, but there had to be some interesting things about how they function as a society that we could potentially learn from.
That is true. That's a good point.
Yeah.
But, it may also just be that they had plentiful herring to eat. And now that we're destroying the oceans with, giant, like industrial scale fishing, they might have to start going to war.
It's possible. Yeah. I mean, I think, that means they were probably living in paradise for, the last, 10,000 years. I would still like to learn about that.
So, yeah, I mean, I think when you talk about the exploration of consciousness and like investing in that space, what like specific, like what kind of like unlocks would you be looking for? What like sort of inquiries would you want to do? Because I think usually when people say like, oh, I'm interested in the consciousness space, it means one of two things. Like they're either trying to start a meditation app or they're trying to like invest in some psychedelics. I don't think you're talking about either of those things.
Yeah. I mean, I think probably there's a field that I'm very interested in called quantum biology, which looks at how quantum effects interact with biological systems.
Okay.
So kind of going down that route, I think there's a lot of fundamental learning that has to happen about quantum effects in biology before we can even try to get to the brain. But there's probably a lot of experimentation that can be done to understand, how do quantum effects and biology interact? And I do think there's something there. It's obviously we're just lacking the tools basically to look for it.
Did you see that very large PDF that was circulating on X about quantum biology like 4 months ago? Like someone had recently written this large, almost textbook-like paper.
Okay, you have to check that out.
I'll try to find it.
Yeah.
Seems interesting.
Yeah, I know some researchers in the space, and I really believe in them. I think they're great. And I think correlated to that is also all the bioelectricity stuff, Mike Levin stuff, which is kind of, again, a generic answer. Everyone loves Mike Levin, I guess, in this space. But I do think a lot of that stuff is really interesting, like how can you use magnetic fields and electricity to drive biology or manipulate it in different ways. And I think ultimately all that stuff kind of feeds into, what is consciousness.
What do you think, like, super lay person's explanation is a hypothesis that you have about how the quantum world impacts consciousness, or at least should impact our understanding of consciousness?
Well, I mean, I guess, I am kind of starting from this place of all matter being imbued with some kind of consciousness, and that our brains are just local maxima of that. So I really have found I'm really interested in sort of animistic type religions, and a lot of the fundamentals there are that all matter has some sort of life force.
Is that like Buddha, like animistic?
Yeah, like Shinto.
Like Shinto,
yeah. I mean, Shinto is the one I'm thinking of, where they believe that all, objects have some sort of life force in them. So I'm kind of aligned with that, rocks, trees, even things that are, not made of living matter. So if that's the case, and I think that's the area that I would just like want to try to explore, and there may be some correlations with all this, and some of these crazy phenomena that you hear about, like the idea that the CIA was using sort of mind readers who could approximate where something was located.
They found the downed plane
exactly.
in Africa. Yeah.
So
remote viewing.
Remote viewing, exactly. Yeah, forgot the term for that. That's exactly what it is. So there's, and that to me also is maybe a little tip of the iceberg thing. It's like, well, these people somehow seem to be hooking into something. And I'm again trying to not be too woo-woo about it, because it's hard to avoid that. But in my personal experience, that feels intuitively sort of like an area I would want to explore.
Yeah, I remember you sent me like a list of 100 startup ideas, and one of them was just psychics, which I loved.
Yeah. We should probably be investing in psychics.
We should
let's
be
be honest.
investing in psychics. And I guess if we're thinking about this from like an entrepreneurial perspective, if you can actually figure out how to identify the level of consciousness in any given piece of matter, that means that you can maybe harness that piece of matter to do something, or at least communicate with that piece of matter, or use it as a conduit for something. Like there's some utility there.
Yeah, I mean,
if you assume that there's some level of consciousness flowing through it rather than it's just a piece of dead, ignorant thing, you might be able to do something with it.
Yeah, I mean, I think it's the goal is for, instead of creating superintelligence, let's be the superintelligence. That's kind of the intent. We don't need a third party, silicon-based superintelligence. We can be the superintelligence in my mind.
Makes sense. Although the silicone does have consciousness running through it, as you just said. So
yeah, true.
Don't prejudice your own carbon intelligence over the silicon.
Yeah, don't judge. Yeah, exactly.
Well, this has been awesome, man. Where can people find you and Biosphere online?
Biosphere.io is the website. And then, I'm on X at Arye Lipman. And all the other places on the internet.
Check it out. Is there anything that you're looking for from the audience? Are you guys hiring any roles at Biosphere or anything like that?
Yes, we're always looking for great people in automation, mechanical engineering, chemical engineering. So would love to hear more folks in that space. And then definitely if people are working on interesting bio products that they want to produce, we'd love to support them as they scale up.
All right. So hit up Arye, biosphere.io. And Arye, this has been great. Thanks for joining us. We will do another podcast at the Biosphere IPO and another podcast with a dolphin when we figure out how to communicate
Let's
them.
do it.
All right.
Thanks.